So welcome back. We're going to keep building as math does. We're moving out of those foundational skills and moving more into some of the algebraic thinking of things. This lesson, the next several lessons, is going to be about solving equations. So we're introducing this concept of an equation. An equation in math is actually it's a sentence. It's a complete thought. It should make sense, just like in English language when you read a sentence. It should make sense to you. Everything's there. You've got that subject and verb and everything else. Equations have that same kind of feel to them. So we're going to start with one-step equations. So a one-step equation, you're going to have something that looks like this. You have like some number where n represents some number. We're going to add 5 to that number, and it has to equal 9. So this is what we call an equation. Notice what makes an equation, it has this equal sign. That equal sign makes it have a left side and a right side of the problem. So one of the things we think about with equations is, since this is an equal sign, it has to be what we call balanced. It's like a scale. So we don't want this or this. We want this thing to be flat, just like a seesaw. We're comparing to those two balanced scales. We want each side of that scale to have the same amount. It's pretty clear that the right side has a 9. It's pretty clear that the left side has a 5. What we're trying to do is figure out what you have to add to a 5 to get a 9. Whatever we do, that's our goal, is to find that value of n. When we do that, we're actually solving the equation. We're trying to figure out the answer. So in solving, we're trying to find that solution, or in other words, we're trying to find that answer. That's our goal. So we're trying to figure out, what can you add to 5 and get 9? Well, thinking about that, I can see that, 4 plus 5 is 9. So that 4 becomes our answer. It becomes our solution. And that's what we're doing with equations. We're trying to seek out the truth. We're trying to make it a true statement. We're trying to make that equation balanced, if you will. So notice how this side represents 9, and this side also represents 9. So therefore, we would say it's balanced. So that's what we're looking for. So the solution would be 4. Now, this is a pretty simple problem, so we really don't need a whole lot of strategy, but there are strategies for harder problems. One thing to pick up on is there's a relationship between the unknown and the known. So we see that there's this addition symbol. Some number plus 5 has to give me 9. So what we see is this addition symbol. Addition is going to be really closely related with subtraction. A lot of times what I will call this is the zero pair. So again, our goal is to get this n value. And what I can do is I can isolate the n on one side by using a zero pair. So I can zero out this 5 by using a negative 5. But if I put a negative 5 on this side, I have to also keep it balanced by putting a negative 5 over here. And that's equation thinking. It's all about keeping this balanced. So when I put that negative 5 on this side, to balance it, I must also put that negative 5 on that side to keep everything in truth. What happens though, these 5s and negative 5s will zero out. This n comes down by itself. And then if I do this math over here, a 9 and a negative 5, or 9 minus 5, that actually gives me my solution of 4. So there's a math strategy that actually also takes me to that value of 4. So one of the goals is to kind of get that x by itself, if you will, get that variable, get that letter by itself. In this case, we're getting n by itself. So let's look at this next equation. Again, there's that equal sign. Equal signs mean we have this right side and we have this left side of the equation. So in my thinking, I'm picturing kind of a scale in my head. I see that this side is a 10. I clearly see this side has a negative 6 on it. And what I'm trying to do is figure out, what can you put with that negative 6 that's going to make this side become a 10? Well, I'm going to need a lot, because I'm 6 in the hole, so I need just 6 to get back up to 0. I need another 6 to get me back up to 10. So it sounds like it's going to be like a 16. 16 minus 6 would give me my 10. 16 minus 6 is 10. So there's my solution. I've kind of did it in my head, and I just say, well, the solution is 16. Now, we can also use strategy. Notice this problem, we kind of see this subtraction, or we see a negative. So we see a negative, I want to use that zero pair, and that zero pair is what makes that turn to a 0. So what I'm looking for is the opposite of a negative 6. Well, the opposite of a negative 6 is actually a positive 6. The opposite of subtraction is adding 6. So I can add a 6 there, but to keep this equation balanced, I must also add 6 to their side of the equation. So I need to also add a 6 over here. And that strategy enables me to get that letter by itself and find the solution. So those negative 6 and positive 6 will zero out. N equals then, and 10 plus 6 equals 16. And that is actually my solution to this problem. So I can actually do it kind of what we call algebraically, using strategies. So let's look at this next example. I have some number plus a half equals negative 2/3. Now we're like, whoa, fractions. This is a little bit more challenging. So I have a negative 2/3 over here. I've got a half over here. Well, that's not balanced right now. So what I'm trying to do is figure out what can I put over here, add to a half, that's going to give me a negative 2/3. Well, my mental strategies aren't very strong here. But I do have algebraic strategies. Addition, subtraction, or this zero pair. Notice how we see addition. When I say addition, that's telling me to get this letter by itself, I need to get rid of this 1/2. And I can get rid of this 1/2 by using its zero pair, a negative 1/2. So now the half and the negative half will zero out. My m is equal to then, and I got to do this negative 2/3 and this negative 1/2. So I have this negative 2/3 and this negative 1/2. So when you're adding fractions, we need a common denominator. And we should see that 6 is a common denominator here. So I'm going to change my denominators to 6's, and I got to remember, well, what did I do to a 3 to make that a 6? Well, I had to multiply that by 2. But remember, to keep fractions equivalent, if I multiply that bottom by 2, I must keep that equivalent by multiplying the top by 2. So negative 2 times 2 gives me negative 4, so I'm going to change negative 2/3 to negative 4/6. And now look at this 2. How did that 2 change into a 6? Well, I had to multiply it by 3, but in doing so, I must also multiply that numerator by 3 to keep it equivalent. So negative 1 times 3 gives me my negative 3. And now I'm ready to combine these together. So negative 4/6 and a negative 3/6 would give me then a negative 7/6. And I have now successfully solved the problem. So negative 7/6 plus a half should give me my negative 2/3. Okay, so that's my solution. Let's look at example number 4. I have some number subtract 3.2 equals negative 5.4. Again, I'm not real good with decimals in my head either, so this is probably more of a paper pencil problem for me. But again, the ideal is I have this negative 5.4 on this side, and I have this negative 3.2 on this side. And what I'm doing is trying to add something to this negative 3.2 that's going to make it a negative 5.4. So what I'm trying to figure out is what can you combine to a negative 3.2 to give me a negative 5.4? Well, thinking about that, it looks like maybe a negative 2.2. Negative 2.2 and a negative 3.2. Actually, that would be negative 5.4, so actually, I'm better at that math in my head than I thought I was. But let's go ahead and play this out just in case we really can't see that. So, again, to solve for y using strategies is to get that variable by itself. So I want to get that y by itself. Since I see a negative 3.2 there, I can zero that out using its opposite. So I want to add a 3.2. So when I see that subtraction, I can actually use that addition to zero it out. But remember, this is equation thinking. To keep this thing balanced, if I add that 3.2 over there, I have to add 3.2 on the other side of the equation to keep it equal. So I will draw the line here to say, let's do this math now. So negative 3.2 and 3.2, that just zeroes out. My y comes in. And negative 5.4 and 3.2, this is debt and income. Those work against each other, so that tells me I have to subtract these. So 5.4 take away 3.2. Looks like 4 minus 2 is 2, 5 minus 3 is 2. The decimal slides down. So I get this 2.2. But also got to pay attention, was it more negative or more positive? Since it was more negative, this is going to stay negative, and there is my negative 2.2 that we talked about. So that would be the solution to that problem. So we would call these one-step equations because, well, it took essentially one step to get to that solution. Unfortunately, when you get into fractions, though, we may have to do some extra stuff over there because we just can't do that. But as far as the equation stuff, it was really just that one step. The math just becomes a little bit more involved sometimes. Okay? So again, seek out the truth, make it balance. Those are some key concepts to solving equations. So that's going to be our theme throughout these next lessons. Stay tuned.